Looks like we got someone. Can you hear me? Can you guys hear me? Hello, can any of you hear me? Comment in the live chat if you can hear me. Alright, I'm going to assume the rest of you can hear me since you're all apparently wet blankets. Oh, that took some restraint. Wet blankets, let's go with that. Okay, so I'm just going to go ahead and start talking. This is going to be a review of JavaScript fundamentals in a markedly different approach to the class material. So the biggest difference you may see if you're already through JavaScript is I'm not going to talk about arrays at all today. We're going to pretend they don't exist as far as this first lesson is concerned. Okay, we're going to talk about functions and for loops before we talk about arrays. So that's probably the biggest difference that you'll notice. But beyond that, feel free to drop any questions you have in the live chat if any of you at any point feel like acknowledging that I'm talking to you. Seriously, guys, what the hell is wrong with you? Anyway, alright, so let's get started. Introduction to JavaScript. I've got a series of slides here. Developer console and you. When developing in JavaScript, we will live, breathe, and eat in the Chrome developer console. We primarily use the console to test code snippets and troubleshoot our code. If, for whatever reason, you are still using a browser that is not Google Chrome, switch now. It is very much in your interest to be using Google Chrome and taking advantage of the browser's stability and taking advantage of its developer tools. So to access the developer console, we right-click on any page, select Inspect, or you could hit Control-Shift-I or Command-Shift-I on a Mac. and it will open up your inspector. And one of the tabs in your inspector is labeled Console. This is the Google Chrome Developer Console. Now, there are 5 JavaScript primitive values. 5 JavaScript primitives. These are different and distinct from the variable types that we learn about in the classic iteration of the class. So try to put that out of your mind for the moment. Okay, the 5 JavaScript primitives are numbers, strings, booleans, null, and undefined. I think I got to imagine we're all pretty comfortable with the concept of what a number is. 8 is a number. Sorry about that. 8 is a number. 101 is a number. Okay, great. Is anybody else able to comment in the live chat? Is anybody even able to see my comments in the live chat? In other words, if I open up the very window, which all of you should be seeing, this live chat right here, anyway, I'm going to keep moving. So we all should be fairly confident with, thank you, Farida, with the concept of what a number is. A string is essentially text. The browser will interpret a string as a line of text with a certain number of characters. And a string can contain a number, but it's still a string. As long as it is wrapped in quotation marks, it will be read by the browser as a string. So this is a string, and this is not. Really wish it weren't trying to autofill like that. String, not a string. Okay. Boolean is simply a binary data type. It can be true, or it can be false. One or the other, and nothing in between. Null and undefined both kind of mean nothing. There's a difference in how they're applied and how they work, and we'll get a little bit more into it later. But for now, what might be helpful is thinking about it as null being deliberately and decidedly nothing. Usually something is null because you have set it to null, or you have removed any value that it contained, or you have decided that under certain circumstances this variable of mine is going to be null, or this property is going to be null. Undefined, on the other hand, is something that you encounter typically when a variable has been declared but not initialized, or a value that the browser expects to find somewhere else has been declared but not initialized. For example, we haven't discussed variables yet, but if I just declare a variable name, then I try to call name, it currently exists as undefined. Or if I declare name and I declare age, and then I try to call a variable called color, which I haven't defined at all, I get a reference error. Color is not defined. So undefined is usually indicative of either an error or something that you left out of your code or something not reading correctly, whereas null is usually a more deliberate value that you assign to something. Okay, let's move on. Exercises. What will the following statements evaluate to? In other words, what will they return? And I'll talk about return and what that actually means in a little bit. For now, we're just evaluating the following 3 statements and thinking about what they're going to evaluate to. Awesome. Thanks, Vinesh. Okay, so we have 10 mod 3. For those of you who aren't familiar with this symbol, it's not a percentage symbol, but what mod or modulo does is it will return or evaluate a statement to only the remainder of a division expression. So 10 mod 3 is going to do the math that tells it 3 goes into 10 3 times and returns a remainder of 1. So that's what I get if I actually put it into my console. 10 mod 3 returns 1. It evaluates to 1. Doesn't matter how many times 3 goes into 10. I can do 100 mod 3 and it will still return 1. It only returns the value of the remainder. So then we have 51 mod 3, which should return 0 because 3 goes into 51 evenly 17 times. 6 mod 2, is there going to be a remainder? No, it's going to be 0. Mod is especially useful for finding out if values or numbers are even. So if a number is even, then that number, mod 2, should return 0. If it's odd, it should return 1. So that's a very common test, a very common logical test that we do in JavaScript. Number, mod 2, to determine whether or not it is even. Again, modulo or modulus, it only returns the remainder of a division function. What will the following statements evaluate to? Notice that these are all strings. This is a string. This hi there, Evan, is a string. Hi is a string, and it's being added to or concatenated with another string. Okay, remember this is concatenation. We're adding 2 different strings together in this case. So, hello world, and then we have this number in square brackets at the end of it. Well, a string, just like an array, for those of you who remember, but again, we're pretending arrays don't exist yet. Strings have indexes or indices to every character that they contain. Strings have indexes for every character that they contain. The first character is always the 0 index. So this H has an index of 0. This E has an index of 1. This L has an index of 2, index of 3, 4. The space has an index of 5, W6, etc., etc., etc. And that number in square brackets following the string is a way to isolate the character at the 0 index of this string. It's a very common syntax that we'll see a lot in JavaScript, and it's a very common practice to access a character or an item by its index. So this should return H. And that's exactly what it does. It returns a string which contains nothing but the letter H. It has isolated the first character in this string. By the same token, we could isolate the second character. And we could isolate the third character. Okay? It's important to remember that indexes start at 0, but if I do hello world dot length, this is going to count how many characters hello world contains. and it should be 1, 2, 3, 4, 5, 6, that space is a character, 7, 8, 9, 10, 11, and 12. It should be 12. Okay? So the length of this string is 12, but if I try to get whatever's at the 12th index, I should get undefined. That's because there's nothing there. The final character is actually at the 11th index, and there's our exclamation mark. So that, again, is an important distinction to remember. Indexes, they start at 0, but if you're taking the length of a string, you count starting from 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 characters. The indexes go from 0 at the H to 11 at the exclamation mark. Okay. Now this next one, we have, hi there, Evan. That doesn't actually need to be in parentheses. Sorry about that. Hi there, Evan. And we're looking for the character at the 8th index. So we have to count. 1, 2, 3, 4, 5, 6, 7, 8. But remember, indexes start from 0. So it's actually going to be 0, 1, 2, 3, 4, 5, 6, 7, and 8. So the character should be that comma. And that's what we get. Okay. Targeting the character at the 8th index of this string returns the comma, the individual character. And we have this expression where we're concatenating two strings, and we want to get the character at the 2nd index of the result. These parentheses, they work just like in mathematics. What's going to happen is these are going to concatenate first, and then the browser is going to interpret this and look for the character at the 2nd index. So it's not going to return undefined because there is no character at the 2nd index of hi. And it's not going to return 0, 1, 2, the V in Evan. It's going to concatenate these two together into one string, hi Evan, and then it's going to look for the character at the 2nd index. So it should be 0, 1, and then 2. So we should get a space. We can try it again with 5, and we get A. Okay. Now how about this? We've got how are you, question mark, dot length. So we need to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We should get 12 again. Remember, because this is dot length, we're not starting from 0. Indexes start from 0. For dot length, we just count from 1. There's 12 characters in here. And if I wanted to isolate that question mark, I would have to select the character at the 11th index. Here we have another concatenation. Hello plus space plus world dot length. So we should get 1, 2, 3, 4, 5, 6, don't forget the space, 7, 8, 9, 10, 11. That's what we get. It concatenates all these 3 strings first, and then it gives us the length of the result. Here we have one that's a little more interesting. Hello.length mod hi.length. So each of these are going to evaluate on their own independently. We're going to get the length of hi and the length of hello, and then we're going to run this mod expression. Okay, so hello.length should evaluate to 1, 2, 3, 4, 5, and hi.length should evaluate to 2. So we get 5 mod 2, which should return 1. That's exactly what it does. We end up with 5 mod 2. That's how the browser reads this expression. Okay, important thing to note here, dot length, it returns a number. not a number in quotes, which would be a string. It returns an actual number data type. That's why I can do this. I can't do hello mod hi. It's going to return a result that means not a number. That doesn't work. You can't run a numeric operator like this on strings. So it's important to understand that .length actually returns a number. This evaluates to a number, and this evaluates to a number. And that's why we're able to use the mod in an expression like this. This is an example of using JavaScript logic and keeping track of the different data types that you're dealing with, and how that can either throw you for a loop or work to your advantage. But it is something to be aware of going forward. If you're ever not sure what is going to be returned or what an expression is going to evaluate to, plug it into your console and actually see what comes out the other side. That should always be the first thing that you do if you ever come upon an error for an undefined error or not a number, or if you're just not sure where your code is breaking. Start console logging things. Start evaluating your individual expressions and figuring out if somewhere you're trying to compare apples to oranges instead of apples to apples. Okay. What will the following statements evaluate to? So here we've got a bunch of backslashes in here. And the backslash inside of a string like this is used to escape a character. So if I had a whole sentence I wanted to write, he said hello to me. If I want to wrap hello in quotes inside of my string, inside of my sentence, this is actually going to break it. If I try to run this, I get an error. The only way to force the browser to read these quotations, not as parts of the string, but actually as a piece of text, a piece of raw text, is to escape them with a backslash. So now, if I try to run that, it's going to return exactly the string that I want. So this backslash indicates to the browser that the following character is going to be read as pure text. No special power to it, no special JavaScript powers. It's not going to do anything except be raw text. And notice that the backslash is not counted as a character. It disappears. That backslash just indicates something to the browser. Now, if you actually wanted to include a backslash, then you would actually need to escape the backslash. I wrote a backslash. Okay, so that first backslash is always going to be interpreted as an escape character, and that is a good thing to keep in mind. So given that, you don't need to memorize this, but it's something to be aware of for the next time if you ever run into this problem or if you ever see it in other code. More importantly, I want you to take that knowledge and apply it to these three exercises that we have here. So we've got hi, backslash, backslash, and we're trying to access the character at the second index. Remember, that's what the number in square brackets following a string indicates. Hi, backslash, backslash. So first, what is this string actually going to evaluate to? If I take this out and just run it, it actually evaluates to hi with one backslash. So if we put that index back in there, what is going to be the second index of the string that this evaluates to? It's going to be 0 index, 1 index, 2 index. So we should get a backslash. By the same token, we have hi, backslash, backslash, dot length. Is it going to return 4 for 4 characters, or is it going to return 3 for 3 characters? It returns 3 because one of these backslashes is actually an escape character, which means it does not get counted. And for a little bit of a more challenging one, we have what's wrong, she said, dot length, mod 4. Let's just take a look, break it apart, and let's just evaluate this string first. Okay, so we see what's wrong, in quotes, with an apostrophe, she said. This is our string. So this backslash was an escape character, this was an escape character, this was an escape character. And then what do we have? We have our string dot length. Well, it should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So what's wrong, she said, dot length should return 24. Okay, and then we have mod 4. Well, how many times does 4 go into 24? It doesn't matter. But does it go into 24 evenly, or does it have a remainder? It goes into 24 evenly, so it should return 0. So the string gets evaluated, the length of the string gets evaluated, and then that length as a number, modulo 4, gets evaluated to 0. JavaScript variables. Variables are containers capable of storing values. They're just empty containers. That's all a variable is. Variables must first be declared with var, V-A-R. They can store any value we've seen thus far. So for example, you could have var is something equals true. Var is black equals true. Var is funny equals true. And this is also something that you might see pretty commonly. You might see variables that simply have a value of true or false. And they're usually used in managing some kind of state. Don't worry too much about that. But it's usually when an application needs to be aware of the state of something. Like maybe the user who's logged in now is a premium member. So they're a paying member. So they might have an is paid subscriber property equal to true. So they can contain booleans, they can contain numbers, they can contain strings, they can contain null. They can be undefined. And they can also obviously contain other things which we have not discussed yet, but we're not going to worry about them just yet. Variables can also contain expressions. They can actually contain a JavaScript expression, and what's going to happen is it's going to evaluate inside that variable. And anytime we call that variable, we're going to get the result to which it evaluates. So var total equals 5 plus 4. Now, anytime I call total, I'm not going to get 5 plus 4, I'm going to get 9. Okay. Variables can contain concatenated values or be used in concatenation themselves. So if I write var full name equals Evan plus space plus Winston, then when I call full name, I should get the full concatenated value. JavaScript variables. So we have var revenue equals 500, a number. Var expenses equals 350, a number. And var profit equals revenue minus expenses. What should we expect profit to be? Well, it's going to be the value of revenue, 500, minus the value of expenses, 350. So it should be 150. And we can test that. If I call profit, 150. Note that it's a number. We have a number minus a number, and it yields a number. Then we have our first name Evan, var last name Winston, var full name equals first name plus space plus last name. So we're concatenating two variables with a space in the middle. And full name gives us the full concatenated string. Concatenating strings will always yield a string. And by the same token, if I try to concatenate a string with numbers, it's going to stringify the whole expression. It returns a string. Also something that's good to know. So what type of data primitive will profit and full name evaluate to, and why? We know that profit evaluates to a number, because it's a number minus a number, and full name evaluates to a string, because it's just concatenating strings. Variables can be updated to reference a new value. For example, var x equals 15. If we do x plus 5, we should expect to see 20. But then if we change the value of x to x equals 3, then x plus 5 should now return 8. And that's because the value of x, the value of the variable x, has been changed. Whereas here it was 15, here it is 3. So it changes, obviously, the result of this expression, even though the expression x plus 5 is exactly the same. The value of the variable has been updated. Okay, so setting up your project folder. When incorporating JavaScript into our projects, we always want to write our JavaScript in an external file. The following steps are easiest if done inside your text editor. Inside your template folder, create a folder called JS. Inside the JS folder, create a new file called main.js. Add a script tag to your index.html at the bottom of your body, just before the closing body tag. And the script is going to look exactly like this, if you follow the directions up here. Now test to see if your JavaScript is hooked up correctly. So let's go ahead and do this real fast. Here I have my template, which should look similar to yours. I've got nothing but Bootstrap, and jQuery, which is about what your template should have if you're heading into week 7. So I'm just going to add my script down here at the very bottom of my body tag. Script type equals text / JavaScript. Source equals JS folder / main.js. So my script is ready to go. I need to actually create the folder and file. So let me go ahead and do that. I'm going to right click on template up here and select new folder. I'm going to name it JS. And I'm going to right click on JS and select new file. Not new folder, but new file. And I'm going to hit save, Control S. And I'm going to save this new file as main.js. And now we're good to go. The last step mentioned here is testing if your JavaScript is hooked up correctly. The easiest way to do that, in my personal opinion, is inside your JavaScript page, simply write console.log connected. Save, open in browser. Let's open my console, because remember, that's where a console.log message should be. And there it is. So now I know my JavaScript is hooked up correctly, and I'm good to go. So I can come back here and delete that. And we're ready to start coding. Okay. Note, if you are not confident with relative file paths, remember this is a relative file path. CSS / main.css is a relative file path. Images / yourimage.jpg is a relative file path. If you are not confident with relative file paths at this point in the course, reach out to your mentor directly now to schedule some dedicated one-on-one time to review file paths. If your mentor is not available and I am not your mentor, reach out to me directly because it is critical, it is crucial, it is essential, it is unavoidably important that you can navigate file paths, relative file paths, with your eyes closed. So I'm 100% serious. If you are not confident with relative file paths, reach out to me or another mentor now and get that solved. Lock that down. Okay? It is inexcusable to continue all the way through the course without being able to confidently navigate a file path. Okay? If you have trouble with it, that's totally understandable. They're intimidating things. There's a lot of forward slashes. Going up a directory requires a special little thing. There's all this stuff, but you should not prioritize anything over understanding file paths if you are not confident with them. I don't mean to scare you unless you need to be scared. Okay? If you do not understand file paths, get scared, reach out to us, and fix that problem. Because it's a hugely weak link that you cannot get around. The first time that you're going to look at code that is unfamiliar to you, you're probably going to encounter a lot of file paths which are unfamiliar to you. And if you can't navigate them, you will be dead in the water. It's not hard. It's not hard. It can be intimidating, but it is not hard, and I'm confident that any one of you could pick it up in an hour with the right sit down, the right talk, the right demonstration. Okay? So please, take it seriously. Don't brush it off. Alright, once your template has been edited, close it. Do not code inside your template. We have added a JavaScript hookup to our template file so that we are now able to use JavaScript in all our future projects. Close your template folder, close it, stop coding in your template folder. This is if you're presumably in week 7 by now, you should no longer be coding in your template folder. That should not be a mistake that you are making. Stop coding in your template folder. Now copy that template folder, paste it somewhere else, rename it, and open that new renamed folder in your text editor, and we can continue. Alright, so a couple built-in JavaScript methods. Notice that they all have these opening and closing parentheses after them. That indicates a method or a function in JavaScript. Whenever you see that, no matter what the word prior to it is, it indicates a function or a method, something that does something. We've already seen what console.log does. It logs a message to the console. Let's take a look at what document.write does. Document.write, I don't know if you can see it, it's pretty small, but it actually writes text directly onto the body of your HTML document. Then we have alert. An alert generates a pop-up with your message inside of it. Finally, there is prompt. And prompt does the same thing as alert, except it asks a question normally. It is normally used to ask a question, and it includes this text field where you can type something in. I can type something in that input field, and look, it actually returns it in the console. So prompt will actually evaluate to whatever the user types in, and that's good to know. If I type in something else, prompt evaluates to the new input which I typed in. Okay. We're going to be using console.log a lot to troubleshoot our code, test our code, and figure out exactly what kind of data types we're dealing with in the future. Important. How is prompt different from alert? Remember, prompt is normally used to ask a question of the user. It invites the user to input something, whereas alert just throws a message at them in the form of a pop-up. What does prompt return? It returns exactly what the user types in. Whatever the user types in response to the prompt is returned. And how do we use what prompt returns? Well, if I wanted to use Evan Winston again, once this prompt is answered, Evan Winston is lost. I can't call it again. I haven't stored it as a variable or anything. So instead, what I can do is declare a variable. Let's call a username, and set that username equal to a prompt, which asks the question, what's your name? And now, when I type in Evan Winston, it's stored there in that username variable. We can see that because I can call it, and there we go, Evan Winston. I can even use that variable now, document.write, username, and it writes Evan Winston to my page. I can insert it into an alert. Hello space plus username. Hello Evan Winston. Okay. So we can store the value which a prompt returns inside a variable in order to use it later. Ask the user for their first name, their last name, and their age. Then print out all three in a full sentence. For example, your name is Evan Winston and you are 10 years old. So things to think about: how are you going to ask for the user's info? How are you going to use the user's info? How are you going to insert the info into a sentence? And how are you going to print the sentence? So let's give this a try real fast. I'm going to go into my main.js file. And how are you going to ask for the user's info? Let's just try a prompt. What is your first name? And we can probably do the same thing for last name and for age. Okay, but in order to use them, we probably need to store them in a variable first. Let's do var first name var last name and var age. And then how are we going to insert the info into a sentence? Well, let's just try concatenating it. Your name is space plus first name, which I spelled wrong up here. First name plus space plus last name plus comma, and you are space plus age plus space years old. Okay, so there we've got our full sentence. We need to do something with it though. We actually need to print it somewhere. So why don't we try a document.write for now. Document.write. Your name is first name, last name, and you are age, years old. I'm going to save, reload my page. Good. Prompt 1, what is your first name? Evan. What is your last name? Winston. What is your age name? My age name is 8. Your name is Evan Winston and you are 8 years old. So there, we got that to work, despite the very awkward wording on that last question there. Let's fix that now. What is your age? There we go. And it prints. It uses the dynamic variable first name, the dynamic variable last name, and the dynamic variable age, and prints all of that into our HTML. Now we have ask a user for their age and print their age in days in a sentence. We've already got our little application set up here to ask for a user's age, stored in the age variable. So let's go ahead and just use that. So first we need to calculate how many days this equates to. So how many days are there in a year? 365. We're probably going to have that expression in there somewhere. Let's go ahead and store that in a days variable. Var days equals age times 365. And then we want to print this in a sentence. Let's do an alert this time. You are space plus days plus space days old. Let's add an approximately in there. You are approximately days old. Let's see if that works. Reload. Kingsley, Papa Giorgio. What is your age? Let's go with 72. You are approximately 26,280 days old. I'm going to take its word on it. Okay, so we prompted a user for some input, stored it in a variable, then we used that dynamic variable in an expression which evaluates to a numeric value that gets stored in another variable, which then gets plugged into a concatenated alert. If we really wanted to, we don't actually need to create a new variable. We could just do it in here, age times 365. We could just include the expression in here. And let's see if we need parentheses around that. Nope, we do not need parentheses. So order of operations allows this to work. All right, moving on. JavaScript logic and control. Control flow in JavaScript relies on Boolean logic. Every JavaScript statement evaluates to true or false. A statement is distinct from an expression. Okay, an expression is a lot of what we've been dealing with so far. 8 plus 4 is an expression, and that evaluates to 12. But every JavaScript statement, we'll see what a statement is specifically in the next slide. We'll see a couple of them. Evaluates to true or false. And these statements are what we use in things like if conditions. JavaScript statements are characterized by comparison operators. We've got the double equals, the triple equals, not equals equals, less than, greater than, less than or equal to, greater than or equal to, and or logical operators. So we've got and right here. We have the pipes for or, and we have the not operator. Whenever you see any of the above signs, the statement will evaluate to true or false. Okay? That's important. Whenever you see any of these signs, whether it's these logical operators, these comparison operators, the statement that you're looking at is going to evaluate to true or false. Comparison operators. Note, equals, single equals, is not a comparison operator. It is an assignment operator. You don't need to know that, but the point is it's not a comparison operator. It assigns value. It does not evaluate for true or false. Okay, if I write 8 equals 5, I get an error. If I write var x equals 5, it's assigning a value of 5 to x. Okay, it's an assignment operator, and I can change that. Now x equals 8. Changes the value of x. It assigns a new value, 8, to the variable x. Okay, so for x equals 5, if we assume that x has a value of 5, let's actually run these. We've got x is greater than or equal to 3. And we see a comparison operator here, so we know that this statement should evaluate to true or false, and it evaluates to true. X is less than 0 evaluates to false. X minus 3 double equals 2 is going to evaluate to true, because it's going to perform x minus 3 first, that's 5 minus 3, and it's going to check 2 equals 2, which is true. Then we have x times 5 mod 5 equals 1. It's going to be false. We have 5 times 5, which is 25, mod 5, which has a remainder of 0, 5 goes equally into 25, equals 1. And that's false. 0 does not equal 1. So those are comparison operators. In contrast to double equals, triple equals checks for strict equality, meaning both the value and type of both sides of the statement must be equal. So for example, with the same value for x equals 5, if we run x equals 5 in quotes, remember this is a string, we get true. But if we try to check x equals 5 as a string, we get false. That's because x is a number. The value of this number is equal to the value of this string, so double equals will work, but triple equals requires that both the value and type be equal. So x triple equals number 5 is going to be true. Just something to keep in mind is null. If we actually set y, var y equals null, and we try to say that null double equals undefined, it's going to get true. But if we try for strict equality, it's going to return false. That's just a potential monkey wrench to keep in mind that you may run into someday, and it's more. I'm more concerned that you bear in mind that there are these relationships that you may not have thought of, which can affect your code or your logic later on. So it might be something to check for if you're ever dealing with a situation like this. And obviously, it is the easiest thing to check for. You just open up your console and write it in here, write in your expression, and check, is it true or is it false? Logical operators. Logical operators allow us to chain together complex Boolean logic. So for and the and symbol requires that both sides of the expression evaluate to true. So if both sides are true, then the whole expression will return true. We can test that out. True and true. And we get true. But remember, both sides must be true, so if we have true and false, returns false. Same thing, false and true, the order doesn't matter, it returns false. Then we have the OR operator. The OR operator only requires that one side be true, so at least one side of the expression must be true. True or true is obviously going to be true. True or false is going to be true. False or true going to be true, but false or false is false. Don't let this get more confusing than it needs to be. At this level, the logical operators are pretty easy to understand. And both sides need to be true, or one side needs to be true. Then we have not, which will really just return the opposite of whatever you're currently dealing with. So if I write not false, I get true. Alright, not true, I get false. And then there's this third one down here where we declare not, and then we evaluate this and statement. So this is going to evaluate first, true and false. What should that evaluate to? That should evaluate to false. So what's not false? It's true. That's pretty much as complex as the principle of logical operators gets. Okay, now you can have an and statement followed by an or statement inside another and statement, all inside a not. So it can get complex, but don't let the number of logical operators confuse you as to the logic that's actually in play here. It's very simple. It's very straightforward. All you need to do is break it down one piece at a time. Okay, so here we have not 8 triple equals 0. Well, does 8 triple equal 0? No, so that's going to be false. And what's not false? It's true. And we have not 5 is greater than or equal to 0. 5 is greater than or equal to 0, so this is going to return true. And not that is going to be false. 6 is greater than 7, or 7 is greater than 6. Well, by nature, at least one of these sides is going to be true. And because it's an or statement, the whole thing is going to evaluate to true. 5 double equals 5 as a string, and 5 triple equals 5 as a string. Well, we're going to get true on the left and false on the right. So it should be false, because both sides need to be true in an and statement. What does the following statement evaluate to? So if we have var x equals 3 and var y equals 8, this is our statement. This is an example of how these logical operators can get complex, but as with before, it's just about breaking them down. So let's check one statement at a time. X is 3. Is 3 equal to 3 as a string? Yes, so that's going to be true. Or is 3 triple equals to 8? That's going to be false. It's an or statement, so we only need one side to be true. True or false, this whole thing is going to be true. But we've got this not statement wrapped around it. So what's not true? It's false. And honestly, we could even stop there because we have a false inside an and statement. So the whole thing is going to be false. But just for practice's sake, let's evaluate the rest. We have 8 is not equal to 8. Well, that's false because 8 is equal to 8. This is going to evaluate to false. This is an and statement, so this whole thing we already know is going to be false. But 3 is less than or equal to 8. That's true. False and true. This evaluates to false. We have a not wrapped around it. What's not false? It's true. So in the end, we have not true and not false, or false and true. The whole statement evaluates to false. That, in spirit, is as complicated as logical operators get. It can look confusing. It can even sound confusing, but really, it's not. Just break it down. Just break it down. And once more, anywhere that you see these comparison operators or these logical operators, the statement is going to evaluate to true or false. It is important to know. It's going to evaluate to and return true or false. And that, in essence, is how we use Boolean logic in all of our JavaScript. Forever. So, it's definitely a good pattern to practice. When using complex logic, especially when using many dynamic variables, just like this example, be wary of inherent truthiness or falsiness of values. I don't want you to remember this, I just want you to be aware of it. It might be something that you need to look out for sometime in the future. Test them in your console using the not operator. So for example, var string equals an empty string. Well, I can test whether string on its own returns true or false with not string. And what I get is true. So therefore, an empty string actually returns false. If I give string a value of hello, and then do the same thing, not string, this time I get false, which means it returns true. What's happening here is an empty string is inherently false, whereas a string with characters in it is inherently true. It's pretty rare that that's going to matter to you, at least until much, much later, by which point it should not be confusing to you, but it's a good thing to know that even things you don't think of as having a truthness or a falseness to them can in fact have them. So let me just copy and paste all these variables in here, and we'll test each of them. Okay, so not string, which is empty, returns true, which means string is false. Not message returns false, which means message is true, and that makes sense because it has characters. Then we have this isFunny variable, which contains false, but in string form. So isFunny returns false because isFunny is actually true, because it's just a string. This is not a Boolean, it's a string. It doesn't matter that it says false. It's a string which contains characters. So, just to build on that example, we have not string or message and isFunny. Well, we know isFunny is inherently true. String is inherently false. Message is inherently true. So this is true. True and true, all wrapped in a not, returns false. Just something to keep in mind. Don't try to memorize that. Just understand that honestly anything can be reduced to a Boolean value if you have to. Conditional statements. I'm going to pause here and just run to the restroom, so if anyone else wants to take a break, now would be a good time, and then we'll jump right back in. Be right back. Alright, I'm back. And Matt, thanks for helping out with figuring out the live chat drama. I was not aware that you needed to actually log into YouTube in order to comment in the live chat, but it's good to know for the future. Okay, so I want to apologize first for the fact that a lot of this stuff feels so dry. It is. It's extremely dry. We're trying to get a lot of the boring stuff out of the way first. And it's okay if a lot of it feels like it's going over your head. It's not about memorizing. It's about familiarizing you with a lot of these principles so that when you see them, or when you see problems caused by a lack of familiarity with them, you are able to solve those problems. You're able to overcome those problems because you'll know how to test for them. You'll know how to actually dig into the code that you're writing and see what is really going on at the most fundamental level. And that's what makes the difference between a JavaScript engineer who has a lot of happy accidents and a JavaScript engineer who really knows what he's doing. I love Bob Ross as much as the next guy, but happy accidents are not going to make you a sustainable professional. Are not going to make your career sustainable. You're not going to be able to sustainably maintain an upward arc by just stumbling into successful code. So that's kind of what this is about. If you guys legitimately feel that this is like too dry, too nitpicky, or too much too fast, please do let me know, because I am testing out a lot of different ways to teach fundamental JavaScript. So if this is too far on that side of the spectrum, let me know. I encourage any kind of feedback. I'm not going to be insulted or feel like I wasted my time. Just let me know. Let me know your thoughts. Let me know how you feel about it. Let me know if this is valuable to you guys, both to you who have already been through JavaScript, or to you guys who may just be starting JavaScript, or people who may not even have approached JavaScript, in which case, bully for you for deciding to join. And I hope I'm not scaring you off. Alright, conditional statements. We apply logical operators and Boolean logic to exercise control over our pages and applications through the use of conditional statements. And conditional statements are if, and else statements. If and else if statements are followed by conditions, which contain statements. Remember, statements evaluate to true or false, so they're followed by conditions, which contain either true or false. If a statement returns true, then the block of code inside that if or else if statement will run. If a statement returns true, then the block of code inside that if or else if statement will run. Let's take a look at what that looks like on the next slide. Else if and else statements are inextricably tied to their preceding if statements. In other words, an else if or else statement will only evaluate if and only if the preceding if statement evaluated to false. I will explain that again once we have something to look at. Alright, var x equals 5, if x triple equals 5 in string form, console.log x must be a string. Else if x equals 5 in string form, console.log x is a number or string equal to 5. Else, console.log, x is not a string or it is not equal to 5. Okay, so we have an if statement, an else statement, an else if statement, and an else statement. So first, what the browser does is we have the value of x equal to 5. It's going to evaluate this statement inside our if condition. And this evaluates to false because x is a number, 5, not a string. So we have an if with a false condition. That means that the code inside our if statement does not execute. It does not execute. It gets skipped over, and the browser then evaluates our else if condition. And the else if condition checks if the value of x is double equal to 5 in string form, and this returns true. So we have an else if statement with a true condition, and that means that the code inside our else if statement will execute. I realize I have a typo here. I'm missing a closing bracket here. Apologies. This evaluates to true, which means this console log is going to run, and we get x is a number or string equal to 5. Okay, because this evaluated to true, and because the code inside this else if statement executed, this else statement does not execute at all. Does not execute. So of these 3 statements, these 3 blocks of code, only one will be executed. The browser evaluates the if statement. If that's true, it's going to run this and quit. If that's false, it's going to evaluate the else if. If that's true, it's going to run this and quit. If it's false, it's going to jump to the else. There's nothing to evaluate in an else statement. It's just going to automatically execute this. Let's look at another one. Var x equals Evan. If x triple equals Evan, then console.log Evan is logged in. Else if x double equals Matt, console.log Matt is logged in. Else console.log not a registered user. So given the value of x, the browser is going to evaluate this condition, which returns true, and then it's going to run this console.log. Evan is logged in. Once it runs that, it's done. It's not going to evaluate this. It's not going to run this. It runs only the if statement, and then it just quits, runs away. Does not evaluate any of the others, because this returned true. This is what I mean when I say that else and else if statements are inextricably tied to their preceding if statement. These are only going to run if their parent, if you will, their parent if condition returns false. Okay? If I had 3 if statements, all 3 of them would independently evaluate. But that is a different thing. Else if and else are tied to their preceding if statement. Here's another one. Var x equals Evan. If x triple equals Sam, which is false, Sam is logged in. So that's false, we skip it. Then we evaluate this. Else if x double equals Lisa, also false, console.log Lisa is logged in. This is false, so we do not execute this. We move to the else. And once we hit the else statement, there's nothing to evaluate. It just executes automatically. Console.log, not a registered user. So false, false, we hit the else, and it automatically executes. Else and else if statements are yes. Let's just go with that. Yes, else and else if statements are used for secure login pages. The logic behind else and else if statements are used for secure login pages. Truly secure pages are a lot more complicated than that, but the mechanism at the most fundamental level is the same. So this is an example of a really simplistic login page. However, you would not actually check the user's name against every single registered user. You wouldn't have else if, else if, else if, else if, else if, else if. There are more efficient ways to do that, and we'll get into that momentarily, actually. So, use conditional statements to evaluate a user's eligibility to enter a bar, for example. So if we have var user age equals prompt, how old are you? If user age is greater than or equal to 21, then they get an alert, you may enter. else if, so this is only going to run if the user's age is not greater than or equal to 21. Else if user age is greater than or equal to 18, then they get an alert. You can come in, but you can't drink. So if their user age is between 18 and 21, they get an alert that says you can come in, but you can't drink. Else, if it is neither greater than or equal to 21 or greater than or equal to 18, then they get an alert that says you're not allowed inside. Let's test this real fast. Paste it into my main.js file. Everything looks good. Reload. How old are you? I'm going to say I'm 25. You may enter. I am not 25, by the way. Just putting that out there. How old are you? 17. You are not allowed inside. And now let's try 20. You can come in, but you can't drink. There we go. It's the same example, but now we have a note. What if the age entered is negative? Well, we don't really want a user to be able to enter a negative age, so maybe we want an error message to pop up that says that's not a bit. Please enter a valid age or something like that. What if we want to give a separate message when age equals 21? So maybe we say congratulations on arriving at the drinking age or something like that. How could we add an additional comment if age is odd? Let's take these one at a time. What if the age entered is negative? So if age is greater than or equal to 21, it's not going to apply. Else if age is greater than or equal to 18, not going to apply. Otherwise, they get a message that says you're not allowed inside. Let's have another else if in here. Else if user age is less than or equal to 0. Then let's give them an alert that says, please enter a valid age. And then it's going to return. Yeah, actually we don't need that return. Please enter a valid age. Let's just do that's not valid age to keep things simple. So if user age is less than or equal to 0, that's not a valid age. And what was number 2? What if we wanted to give a separate message when age equals 21? Okay. Well, let's change this if user age is greater than or equal to 21 to if user age is greater than 21. And then after that, we're going to have another else if. Else if that says if user age equals 21, then we'll get an alert that says congratulations on, I don't know, on your 21st birthday. Okay, so that's if they're 21, they get a message that says congratulations on your 21st birthday. Doesn't make sense, doesn't have to. And then the last one is how could we add an additional comment if the age is odd? Now this is important. We don't want to replace the comment that they get based on their age. We simply want to add an additional comment if their age happens to be odd. So if they're 21, we still want it to say congratulations on your 21st birthday, and we want to say that's an odd age or something like that. If they're 47, we want to say you may enter, and that's an odd age. So, in order to do that, we're not going to do another else if statement. we're going to do a completely separate if statement. So, and this is going to check if user age mod 2. Remember, to check if a number is even, we want to see mod 2 equals 0. So to check if it's odd, does not equal 0. This means that user age is an odd number if this returns true. Then they're going to get another alert that says that's an odd age. Okay, and we put this in a separate if statement because we want this to evaluate no matter which statement ends up running from this batch of conditionals. Because we want this to be an additional alert, not a replacement alert. So the browser is going to evaluate one of these blocks of code and this. Save, reload, say I'm 47, I get you may enter, and then I get that's an odd age. So that works. Okay, 2 independently evaluated if statements. Loops. Loops allow us to execute a block of code multiple times and to change each iteration. So for example, without a loop, to print all numbers between 0 and 10 to the console, I would need to write console.log 0, console.log 1, console.log 2, console.log 3, etc., 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 all the way to 10. And that would be, 11 lines of code. Instead, I can use a for loop. This is what our for loop is going to look like. Don't worry, I'll explain what we're seeing if it's confusing to you. But this is 3 lines of code, and it prints the numbers 0 through 10. The alternative to a for loop, I really just have it here so that you can see it and recognize it, because it is very likely to be something you run into at some point in time out in the wild. And this is a while loop. It's very, very similar to a for loop. There are situations where a while loop is, it saves you a little bit more code, but for the most part, a for loop is generally preferred, more effective, and it is definitely what we use here at Codify. So it's really just here to show you. It does the exact same thing. I'll talk about some differences between the while and for loop in a little bit, but we can test this out. We get, oh yeah, that's right. It's not actually logging this 11. See this little arrow next to it? That's just something that the Chrome console does. It shows you the most recent iteration of that iterator. So it works though. We get the numbers 0 through 10. It works the same way as a for loop. This is a while loop. Not going to ask that you know while loops or are comfortable with while loops. It's not that big of a deal. You don't need to pay them any attention, and by the time you do have to pay them attention, you'll be so confident with for loops that you can write a while loop anyway in your sleep. Okay, so the for loop. This is the for loop that we were dealing with before, exact same one. And the syntax of it is, we have for, and it's essentially for followed by open and close parentheses. And remember what I said about that. Whenever you see opening and closing parentheses, it indicates a JavaScript method or function. So this is a built-in method that takes 3 arguments. Okay, it takes the base value of our iterator. We usually start with 0. We declare it as var I just because I is the most common. I is the first letter of iterator. It just works. It's convenient, easy to remember. So var I equals 0 is the base value of our iterator. Then the second argument, this I is less than or equal to 10 is the terminating condition for our loop. In other words, remember, this is a comparison operator. So this statement is going to evaluate to either true or false at any given time, right? 7 is less than or equal to 10. Okay. 7 is less than or equal to 10. It's going to evaluate to true. 12 is less than or equal to 10. It's going to evaluate to false. That comparison operator makes this a statement. Which will always evaluate to true or false. So, as long as this statement evaluates to true, the for loop will continue to run. As soon as the statement evaluates to false, the for loop will breaks the loop. Okay? That's the terminating condition, the second argument. And then the third argument is the change to each cycle. So we take I and we set it equal to I plus 1. This is a very common brand of JavaScript logic. You have I equals I plus 1. Remember, single equals is an assignment operator. It assigns value. Doesn't evaluate, doesn't compare, it's not a logical operator. It assigns value. What this is doing is it is updating the variable I by setting it equal to the current value of I plus 1. So in other words, we start the loop with I equals 0. 0 is less than or equal to 10. That's true. So we console.log 0. And then we update the value of I equals 0 plus 1. So the next time we run the loop, I equals 1. 1 is less than or equal to 10. That's still true. Console.log 1. And now I equals 1 plus 1. So when we run the loop again, I equals 2. 2 is less than or equal to 10. That's still true. We console.log 2, and I is equal to 2 plus 1, etc., etc. So that's what we're doing with our iterator. We start at a base value of 0. We're logging it to the console every time we run the loop. And every time we run the loop, we are adding 1 to the value of I. We're increasing it by 1. We're updating its value from 0 to 1, and 1 to 2, and 2 to 3, until I equals 11. And 11 is less than or equal to 10 is going to evaluate false, and the loop will cease to run. It will break. That is how the for loop works. It looks a lot more complicated than it is, but it does take some practice and mileage to get really comfortable with it. By the end of the course, you should be able to write for loops in your sleep, and you should also have discovered several much cleaner and more efficient alternatives to the for loop. But definitely not going to get into that today. Okay? So, given this for loop, what do you expect to see in the console? We have for var I equals 0. I is less than or equal to 100. That's our terminating condition. I equals I plus 10. So we start with a base value of 0. As long as I is less than or equal to 100, we will run the loop. And each time we run the loop, we are increasing I by 10. So first we're going to console.log 0, and then I is increased by 10. 10 is less than or equal to 100, we console.log 10. Then we should console.log 20, 30, 40, 50, 60, 70, 80, 90, 100. Then I is 110. 110 is less than or equal to 100, evaluates to false, and the loop breaks. Let's go ahead and test it. It's the wrong code. 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Okay? And this is all because we are console.logging I. There are plenty of ways to use I, the iterator, inside the code contained in the for loop. We're approaching something very simple here by just actually console logging the value of our iterator. An example of a more complex example, slightly more complex, is the next example. We have var myString equals hello world, and a for loop, var I equals 0. I is less than myString.length. This is the terminating condition. I equals I plus 1. So, first of all, what is the terminating condition? How many times is our loop going to run? What's the numeric value of myString.length? Well, let's count. We have HELLO spaces 6, W7, ORLD, 11. So this equates to I is less than myString.length. I is less than 11, pardon me. I is less than 11. That's our terminating condition. And what are we logging to the console? We're not logging I anymore. We're logging myString at the I index. So we're logging the character at the I index of myString. So when I is 0, what is the character at the 0 index of myString? It's going to be the H. Then we increase I by 1. When I is 1, we're going to log the character at the 1 index, the E. Then the character at the 2 index, the L, etc., 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 until I equals myString.length. This evaluates to false, and the loop breaks. HELLO space WORLD. This little 2 here, it's something the Chrome browser does. Whenever a console.log message or command is equal to the one it just ran, it just kind of stacks them and tells you how many times you're seeing that message. It has a practical purpose, but it's a little confusing in this example. But it's our code is working completely perfectly. That 2 is just something that the Chrome browser does. Okay, so this is how we are logging every single character in a string to our console using a for loop. We loop through every index of our string and log the character at that index to the console. MyString, square brackets, index, and we use the value of our iterator I as the number index. Okay, this is classic JavaScript logic. Now, given this, what do you expect to see in the console? We have an if statement inside a for loop. Fun. For var I equals 0, I is less than or equal to 100. This is our terminating condition. I equals I plus 1. If I mod 5 equals 0, console.log I. So let's start, pretty simple. If we didn't have this if statement, what would we expect to see? We should expect to see the numbers 0 through 100. I is increasing by 1. We stop when I is greater than 100. I starts at 0. We should see the numbers 0 through 100. Now let's put that if statement in. Now we're only going to see I in our console if this returns true. If it doesn't return true, are we going to see anything? No. There's no else statement. There's no code after our if statement. There's nothing else. So only if this returns true are we going to see anything in the console. Now what does this statement actually check for? It checks to see if the value of I divided by 5 has a remainder of 0. So in other words, if I is evenly divisible by 5, only when that is true are we going to see console.log I. So think about it. Is 0 divided by 5, does that have a remainder of 0? Yeah, it does. So we're going to see 0. What about 1? Nope. 2, nope. 3, nope. 4, nope. 5. 5 mod 5 equals 0. That's going to be true. I mean, let's check it real fast. 3 mod 5 equals 0. False. 4 mod 5 equals 0. False. 5 mod 5 equals 0. True. Okay, so we're going to see the numbers 0 to 100 in increments of 5. That's what we should expect to see from this for loop. And that's exactly what we get. This if statement inside a for loop is also very common. It's very common if we wanted to be sure that we were getting all numbers divisible by 5. Now, you might say, like, why couldn't you just do this? Why couldn't you just change the for loop to I equals I plus 5 and then get rid of the if statement altogether? Well, that should work, right? And it does. It gives us the exact same thing. But this loop, as we see it now, it only works because I has a base value of 0. If I started at 1, then we're going to see 1, 6, 11, 16, 21, 26, 31. That may not be what we want. Maybe we want to ensure that we're only getting numbers which are evenly divisible by 5, or in increments of 5. So, for something like this, if we try it again, our original for loop, change the starting value of I to, let's go 21, we're still only going to get the numbers that we want. So that's why this is just a more precise batch of code. It gives you a little bit more control over exactly what is going to be returned. And oftentimes that's going to be what you need to make sure your applications are doing the right thing, or that your users are getting the right information. Okay. Given this for loop, what do you expect to see in the console? If our I equals 0, I is less than or equal to 100, I equals I plus 1. If I mod 3 equals 0, and I mod 5 equals 0, then we console.log I. So we have one statement that will evaluate to true or false, and another statement that will evaluate to true or false, and both of them are wrapped around an AND logical operator. The whole statement will evaluate to true or false. What does an AND statement require? It requires that both sides return true. So, in order for this if condition as a whole to return true, and for us to see I logged to the console, the value of I needs to be both evenly divisible by 3 and evenly divisible by 5. So, are we going to see 3? No, because 3 is divisible by 3, but it's not divisible by 5. Are we going to see 5? No. 5 is not divisible by 3, though it is divisible by 5. We're going to see 15, and we're going to see 30, and we're going to see 45, and we're going to see 60. 0, 15, 30, 45, 60, 75, 90. we only see numbers which are evenly divisible by both 3 and 5. So that's the beauty of an if statement inside a for loop. Functions. You can't have functions without fun. Okay. Once again, this is all about introducing the fundamentals of JavaScript. Fun again. Fundamentals of JavaScript. If you guys respond well to this, then the next review session along these same lines will build on this, again, in a manner that deviates from the way Codify's course material currently presents a lot of this information. Most of it will not be new, but it will be hopefully presented in a way that is more actionable for a lot of you. Specifically, if there is a round 2 of this, we're going to start discussing, well, arrays, obviously, and a lot of the methods that you can perform on arrays and HTML collections. But more importantly, we're going to talk about functional programming and what that means. Just to introduce it here, functional programming is a means of making your code much cleaner, much shorter, much easier to maintain, and easier to troubleshoot. Just in general, easier to handle and easier to read. And functional programming is kind of taking the professional world by storm. So it's not a new language or anything. It's not new. It's not even new syntax in most cases. It's usually just new ways of structuring your JavaScript. So that's what I would like to start introducing in the next session of these, if there is one, if you guys respond well to this. So that's the goal there. For now, we're just going to set ourselves up with all the necessary building blocks, and then we can really get into the fun stuff. So functions. Functions allow us to wrap code segments into reusable packages. This is an example of a function which takes no arguments. Function greet. All it does is create an alert that says hello. Notice I declared the function and nothing happened. And that is because in order to actually run the function, you need to invoke it. So first I declared it with that function syntax, and then I can invoke it. And then I get my pop-up that says hello. Okay? This is declaring a function, and this is invoking a function. And once more, this is a function which takes no arguments. By contrast, here's a function which takes one argument. So I'm going to go ahead and declare my function, greet, which takes an argument, which is currently here given the placeholder of name. So name, it's not a variable, it's not something that has been previously declared. Name here is simply the placeholder name for the argument that this function expects to see. What that means is when I invoke this function, it is going to expect to receive an argument like this. So in this context, name is the string Evan. And if I hit enter and invoke it, I get hello Evan. It's probably too small for you guys to see, but it says hello Evan. And I can do that with any valid argument. Hello Jose. Hello Jose. I could even do it with something weird like a number. Hello 8. Should have done 11. What was I thinking? Anyway, so that's the function of name in this function syntax. It's a placeholder for an argument that the greet function is going to expect to receive. What happens if I don't give it an argument, even though it expects one? Well, it's still going to run the function, but it says hello undefined. And And that's because name in this context is undefined. And see, what it does is it takes name and it plugs it right into the alert message. Nothing too complicated, but that's a function which takes an argument. Functions which take arguments need to be invoked with arguments. Greet will just give us an alert that says hello undefined, which we just saw. Greet with the string of Evan inside of it as an argument gives us an alert that says hello Evan. Here's an example of a function which takes multiple arguments. It takes 3 to be specific. Name 1, name 2, name 3. Once again, these argument names, they're completely made up. I could call them X, Y, and Z if I want. I could call them elephant, zebra, and lion. Doesn't matter as long as I am consistent in how I use them inside the actual function. Okay, so if I change name 1 to X here, I'd have to change it to X here as well. Let's do that. Y, Y, Z, and Z. That shouldn't be there. Okay, so this is a greet function which accepts 3 arguments, all of which it inserts into an alert message. That's me. I missed a plus sign there. There we go. Okay, so my function has been declared, and now when I invoke it, let's try it with no arguments first. I get hello undefined, undefined, undefined. And if I try it with arguments, Evan, Matt, Sam. Hello Evan, Matt, and Sam. Okay, it uses all 3 of those arguments. Now these are the functions that we've been dealing with so far are all functions that do something. They run an alert command or a console.log command or a document.write command. We haven't been overly focused on functions which actually return a value. But here's an example of a function square which actually returns a value of num times num, with num being the argument it should expect to receive. Okay? So when I run this function, when I invoke it with an argument, it should return whatever this evaluates to. So it doesn't execute an alert. It doesn't execute a console log. It doesn't execute document.write. It simply returns a value. Let's try 8. I get 64. It's not that interesting, but maybe we have a prompt. We have a user prompt. How old are you? That asks for a user's name, a user's age. How old are you? I'm 4 years old. So if I call age now, it's got the value of 4 stored in there as a string. All right, scratch that example for right now. The point is, I can run that function with any argument that I want, and this could just as easily be a dynamic variable that comes from a user's input, or comes from some other state or condition that I can't predict right now. Maybe I don't know what the number is going to be, but I want to set up a function that returns the square, or that number squared, no matter what. And I want to store that somewhere. Var squared equals square function of 5. So now squared is going to contain the value which was returned by this. I can come back to and use in the future. Okay, here's another function that returns a value, and a return is best thought of as an output that is sent back to us. Just like anything else, that output has value when it is stored in a variable and used in some kind of specific context. So let's try this function. The area of a square with a length of 5 and, well, and a width of 5 of a rectangle, not necessarily a square. We get 25. And we can put any arguments we wanted in here, and it will return whatever this expression evaluates to. So here's a function called capitalize, which actually takes a string as an argument. Remember, str is just a made-up placeholder name. It doesn't tell the browser that it should expect a string or anything like that. It's just a made-up placeholder name. And what capitalize does is first it checks if string, str, that argument, if its type of is a number, then it simply returns this string, which says that's not a string. So that may be confusing. Don't worry about the specific code here. This is more about the pattern of the function. Okay, so type of str triple equals number. This is a statement that will return true if str is a number as opposed to a string. If its data type, if its primitive type is a number. And if so, if that's true, then we get this message returned from the function. That's not a string. Otherwise, nothing happens in this if condition, and we move on, and we return instead all of this. And this expression evaluates to the string with the capitalized first letter. Okay, my question here, why don't I put this in an else statement, is because return actually causes a function to end wherever it happens. So if the if statement is true, we return this and we break out of the function. If it's not true, we skip it and we return here and break out of the function. So we don't actually need this to be in an else statement. That's a subtle difference that it will take some practice to master, but it's pretty straightforward logic that it's easiest to get comfortable with when you actually encounter it in your own code. So you're very liable to encounter it when you're working on the Zodiac application, for example. And when you do, remember this function. Maybe come back to it. Maybe think about, why didn't I put this return in an else statement? Anyway, let's go ahead and test this out. I declared my function. First, let's try with a number. Capitalize 9. That's not a string. Perfect. So that works. Capitalize Peru. Let me get Peru with a capital P. It's perfect. That's exactly what I need. Exactly what I want. Okay, now given this function, functions can be stored inside variables. For example, we can have var city equals Paris, a string, the lowercase p, and var capital equals the capitalized function with the city variable plugged in as its argument. So what's going to happen is if we run capitalize Paris, we return Paris. This value is going to be stored inside the capital variable. So just to demonstrate, var city equals Paris. var, well, before I put it in capital, let's try it. Capitalize city. Returns Paris. Now var capital equals capitalize city. So if I call capital now, it contains and stores the value Paris with a capital P. Another thing I can do is, rather than go through all that noise, var capital equals the function capitalize. Oh, sorry. Should not. Equals the function capitalize. The reason why I don't want these parentheses here, and I should really take it out there, is because I'm not trying to invoke the function as is, especially since it has no argument here. I'm not trying to invoke the function. That's what those parentheses do. They cause the function to run and be invoked. I'm just trying to store the function inside capital. Now if I call capital, it actually contains the full function. I can see that. That's great, but how does that really help me? Well, now I can call capital and invoke it with an argument. And capital, the variable, now invokes the function which it contains with this as its argument, and it returns and stores, well, it returns the correct value. And it still contains our original function. So this is all about storing functions and variables. It's more for you guys to know that it's a thing you can do, a thing you might see, and if you ever see a variable that is not a function followed by invoking parentheses like this, it's probably because it contains a function or a method or something along those lines, and the method inside is being invoked at that point in time with a specific argument. It's complicated. It's not necessary that you feel 100% comfortable with this. I just want you to know that it exists, that it is a thing that you can do. And you can use this way of setting up your data to help variables and functions inherit certain arguments. And they can inherit them all the way down the line if you have functions within functions, all stored in a variable. And it's good to know that it's out there, especially when you look at other people's code or more advanced code that's out there today. You will hopefully recall this lecture and have the tools you need to start deciphering all of the inherited properties and arguments that you're looking at. Parameters and arguments. Alright, okay, so this is an example of a function declaration. It's where we just write function, function name, and some code inside of it. By contrast, a function expression is a function with no name, an anonymous function, some code inside, stored inside a variable. Stored inside a variable. This is they're both perfectly valid. There are some advantages to one over the other in certain scenarios, but they're both perfectly valid. Something that you should keep in mind is if you store an anonymous function in a variable like this, then if you ever change the value of this variable, that function is lost. Okay, if I have var sum equals function, let's do x plus y, return x plus y. Let's make sure it looks for those arguments. Okay, now sum contains a function. I can run sum, 4 and 2, return 6. But if I later in my code write sum now equals 10, then my function, this one in here, is lost. I can no longer access it. I can no longer call it. I can't use it at all. So that's something to keep in mind. But when you hear the words function declaration versus function expression, this is the only difference that they're talking about. All right, here are some challenging little exercises. Complete the following functions. Write a function that returns true if a number is even and false if it is not. So what might this look like? Oh, let me do this in my actual code, my text editor. Function is even. It takes a number as an argument, and it's going to return either true or false. True if the number is even. So let's have an if condition. If num mod 2 equals 0, then num must be evenly divisible by 2, which means it's even. Otherwise, return false. Once more, this is another situation where I don't need this inside an else statement, because we're either going to hit this return and break out of the function, or this is not going to apply at all. We hit this return, and it's false anyway. Let's test it out. If I run is even 20, true, is even 21, false. Okay. There is a shorter, more concise way to write this function, which I do kind of want you to know. Don't memorize it. Don't feel like you need to be comfortable with it right away. But I want to put it out there because I think you guys should start exploring ways to tighten up your code, especially if you've already gone through JavaScript or gone through it a couple times. And the way to do that would be this. Function is even num. I'm not talking about arrow functions or anything like that. It's much more simple than that. And this function is only going to have one return. And what it's going to do is return num mod 2 equals 0. Remember, this expression is going to evaluate to either true or false. So whatever num is, this expression, whether true or false, is going to be returned. And I actually wrote is even. Let's make it is even 2, and let's test it. Is even, Jesus Christ, is even 2, 42, true. Keep writing is even. I don't know what that's about. 71, false. Okay, so there's no if, there's no separate return, one for true, one for false. We're simply returning whatever this expression evaluates to. Whatever this statement evaluates to, true or false. Okay. So it's a type of logic, a type of thinking that you just want to plant the seed for in there and keep an eye out for, because this is an extra. This is 3 lines of code. This is 6. This is 77 characters. And this is 47. I mean, that's like a 33% decrease in characters. In one function, it doesn't look like a lot, but if your function is more complex, your code is really long, it could really go a long way. Just something to think about. Okay, next one. I'm also not seeing any additional questions from you guys, so I'm assuming you're all just on the right track. So write a function that returns the factorial of a number. How many of you guys remember what a factorial is from high school or middle school? A factorial is a number multiplied by all of the, every number beneath it incremented by 1. So the factorial of 4 factorial would be 4 times 3 times 2 times 1. And the factorial of 0 is always 1. But that's a factorial. And the way to do this is quite a bit more complicated, actually. Here we go. Function, factorial, num. What we want to do is we want to start with kind of like a base value. Let's call it result. Give it a value of 1. And we're going to need a for loop here. For var I equals 0, our terminating condition is going to be I is less than or equal to num. I equals I plus 1. Another way to write I equals I plus 1 is simply I plus plus. Just a shorthand for I equals I plus 1. And what do we want to do here? We want to update the value of result each time we run through the loop to the value of itself times I. We don't want to start with 0 because we don't want result to ever be 0. Because even a factorial of 0 is 1, right? So we can start from 1. And we already have 1 times 1. So if we wanted to, we could even start from 2 to really save code. But that's impure logic I'm not going to worry about right now. Okay, so we don't start with 0 because we want result to always be at minimum 1. And what should happen is if num is 4, then our for loop is going to do var I equals 1. As long as I is less than or equal to 4, we add 1 to I. So result equals result 1 times I 1. Result equals 1. We add 1 to I equals 2. 2 is less than or equal to 4, that's true. Result equals result 1 times 2. Result equals 2. We add 1 to I becomes 3. 3 is less than or equal to 4, that's true. Result equals 2 times 3, 6. We add 1 to I, and I equals 4. 4 is less than or equal to num. 4 is less than or equal to 4, still true. Result equals 6 times 4, 24. And then we add 1 to I equals 5. 5 is less than or equal to 4 is false, so the loop breaks. And then what do we do after the loop? We return result. Okay, let's give that a try. Factorial 4. Factorial 10. I'm going to take its word for it on that. Okay, so that works. Last exercise I have involves kebab case and snake case. If you're not familiar with what those are, I'm going to show you exactly what that looks like. Kebab case looks like this. Okay, every word is separated by a hyphen or dash, if you will. And snake case looks like this. And then, of course, you should know by now that camel case looks like this. Okay, so we want to write a function that converts a string from kebab case to snake case. And this is something where you probably have to Google, especially if you really are in week 7. You definitely have to Google it. So I'm going to let you guys take that and go with it, see if you can solve it on your own. one thing to watch out for is one of the very common solutions to this involves using a regular expression and something that's called the dot replace function on a string. I'm just going to say this right now. Dot replace typically only replaces the first occurrence of whatever argument you tell it. If you use it in conjunction with a regular expression with a global modifier, it will work for you, but it's kind of a one-time exception case. So if you solve it that way, that's great. Congratulations, you did the right research. I just don't want you to walk away having the wrong impression about the dot replace function. But I'll talk plenty about that next time we do this. Okay, I'm going to go ahead and call it a day here. Some of the topics that we will explore next time, if this happens, are going to be scope and a lot of the problems that scope can cause, being aware of scope. We're going to be looking at let me write these down here. So scope and execution contexts. We're going to be looking at the this variable in JavaScript. We're going to be looking at arrays and array methods, which are many and huge and supremely useful. And we're going to talk about functional programming and pure code. Well, pure logic. Okay, functional programming is the big one. That's kind of why I'm trying to instill a lot of these fundamentals to you guys. In order to be a successful functional programmer, you really need to have a good understanding of what your JavaScript is doing behind the scenes. So this is part of it. Especially when we get into array methods, we're going to all try to be very, very aware of what every method is returning at any given time, and that's an easy thing to overlook if you're just trying to solve a bigger problem. It's easy to not see the trees for the forest, such as it is. Alright, so thanks for coming. I hope this was useful to some of you guys. If you have any feedback, please feel free to message me directly. Alizia, I can certainly provide a PDF of these slides. That's not a problem at all. So I'll go ahead and do that. If you guys have feedback, feel free to message me directly, post in the Magic Hours channel. I'm going to try to create a doc for all of you to leave any feedback so I can start recording it. That would be helpful. And if you're watching this in the future, then same goes. Please, at any point in time, even if it's 3 weeks from now, when you finally get around to watching this, reach out to me if you have feedback on this video. I am actively trying to edit some of the JavaScript component of Codify's course material. So if this is more helpful in any way, let me know. Might be easier to judge after we've had another session or two and all of it starts to come together, but if this didn't scare you off completely, I call it a win. So, All right, thank you everybody, and I'll see you later.